It is possible to find the center of mass of a person using the second condition of static equilibrium. The sum of all torques is equal to 0. You set a board across two scales, and you separate the scales according to the height of the person, and then you just record the weights, okay, for the person, okay, at each location, one towards the head, one towards the feet. After you set the scales to 0, so in other words, you take the weight of the plank out of the picture by tearing your scale to 0. So how does this work? Well, all of the mass of this person looks like it comes from one place on. We're not really sure where. We'll locate it here. Let's let this be the point of rotation that all torque is measured from. Therefore, this distance then is measured to be x, and that's what we want to find. What's the center of mass of the person relative to his feet? So let's get started. We'll say the sum of all torque does equal 0 equals, okay, well, we know the total weight of the person is going to then be 48 plus 65. And then all of that weight looks like it comes from that place there, which we've labeled an x distance from the balance, or from that left scale there. And that'll be a negative torque because that's going into the clockwise direction. And then we'll have a torque generated going upwards this way, okay, from this scale here of 65 pounds. You know, do think a Newton third law pair. 65 pounds pushing down, and then upwards would be a force. That's the reaction pair. So we'll say plus 65 then, multiplied by 1.65. And all those torques would equal 0. Well, then our job is just simply to find x in this case, and x is equal to 0.95 meters. So what that means is 0.95 meters above this person's feet is where the center of gravity is for that person.